All right, so we continue. Example. So we have to expand and simplify n minus 2 n plus 5. So to expand this binomial, so we pick n, the first component, or the first variable used to multiply everything over here. And over here we have minus 2 used to multiply all this. So we expand n times n is n squared, n times 5n is 5n. Minus 2 times n is minus 2n, minus 2 times 5 is minus 10. So we group like terms, so we have n squared, 5n minus 2n is positive 3n, the minus 10. Since they are not like terms, the answer remains like that. Let's take another question. We have 4p plus 1 times 4p minus 1. So once again, you take the 4p, use to multiply everything over here, which is 4p minus 1. And we take the positive 1 over here, use to multiply everything at the right-hand side. So we expand 4p times 4p is 16p squared. 4p times minus 1 is minus 4p. 1 times 4p is positive 4p. 1 times minus 1 is minus 1. So minus 4p plus 4p is 0. So we are left with 16p squared minus 1. Okay, so we now move on to perfect square. So when you have x plus y all squared, we know this is the same as the same sign. So to be x plus y, x plus y. Then we can expand this, which we have already done in the previous example. So by now, we should know that this is the same as x squared plus 2xy plus y squared. Also, when you have x minus y all squared, this is the same as x minus y, x minus y. And the expansion gives you x squared minus 2xy plus y squared. And we need to understand that, note that a plus b all squared is not the same as a squared minus b squared, or a squared plus b squared. Take note of that. So we found some students have been making mistake like that. So let's take note of that. Now let's take some example. Expand and simplify. Let's say 2x plus 3y all squared. So this one means that this is the same as 2x plus 3y, the same 2x plus 3y. Okay, the same sign. So we'll take our first 2x, use it to multiply everything here. So you have 2x plus 3y. We take the positive 3y here, use it to multiply everything in this bracket. So you have 2x plus 3y. So 2x times 2x is 4x squared. 2x times 3 is 6xy. 3y times 2x is 6xy. And 3y times 3y is 9y squared. So we're going to have, we group like terms, we have 4x squared 6x plus 6sy is 12xy, then plus 9y squared. So we move on. So it means that the shortest way, if you have a plus 3 all squared, it simply means that you take the first one, you square it, you have a squared. Then a times 3 times 2 gives you 6a. Then the last number, which is the constant here, 3 squared, which will give you 9. So with this, we can see that a squared plus 6a plus 9 is a perfect square. It's a perfect square, okay? And can be written as a plus 3 all squared. So what it means is the coefficient of a, okay, is divided by 2. That's what gave us the 3 over here. Then you will square the last digit. The 3 square gave us the 9. Okay. So take note of that. Let's take some example on perfect square. So you understand it more. Find the value of a if x squared minus 5x plus a is a perfect square. Okay. So to solve a question like this, what we need to do always is to half the coefficient of x. So if you look at the half, the coefficient of x, the number attached to x is the coefficient of x. So the coefficient of x is minus 5. So we multiply by half, and we'll get minus 5 divided by 2. Then we will square it. And when you square negative 5 over 2 all squared, you'll be getting 25 over 4. So it means that my a is 25 on 4. So 25 on 4 is the perfect square. Is the perfect square. Is the perfect square. Let's take another example. So if y squared minus a plus 1y plus 9 equal to y minus 3 all squared. Okay. Find the value of a. So what we need to do first is to expand the right-hand side. So we have y squared minus a plus 1y plus 9. We need to expand the perfect square. So this will be y squared. Okay. So the first one squared, then y times minus 3, which is minus 3y, times 2, give you minus 6y. Then minus 3 squared gives you 9. So take note of the expansion of that always. And so if you look at it carefully, we need to compare. So comparing with the right-hand side, the left-hand side with the right-hand side. Comparing with the right-hand side, you see that the coefficient of y is minus a plus 1 equal to the coefficient of y here is minus 6. So we make a the subject. This negative will cancel, because negative is here, negative is here. So it's dividing through by negative 1. It cancels, you are left with a plus 1 equal to 6. Then we make A the subject, which will be 6 minus 1. And A, therefore, is 5. Let's take another example on perfect square. So find the value of K if y squared plus y plus K is a perfect square. So don't forget, what you need to do is to take the coefficient of y. So you have the coefficient of y, okay? And if you take the coefficient of y, it's 1. So that 1, you multiply by half. Now answer is half. And what we need to do is to now square it. And when you square it, you have half square, which is equal to 1 over 4. So therefore, our y, sorry, we are using k. So therefore, our k is equal to 1 over 4, 1 over 4 to be the answer. Well, an alternative to all this perfect square question is to use the formula b squared minus 4ac equal to 0. So if you have a perfect square, then your discriminant should be equal to 0. And so if you look at this formula, the coefficient of b here is 1. So we have 1 squared minus 4. The coefficient of a, okay, is 1. And the coefficient, the c is a constant, which is k, equal to 0, because every quadratic is of the form ax squared plus bx plus c equal to 0. So the coefficient of x squared is a, coefficient of x is b, and a constant is c. So that's what I just did over here. So now we have 1 squared being 1. 4 times k gives you 4k equal to 0. So we have 1 equal to this cross it turns positive 4k, divide through by 4, and your k is 1 on 4. So you see that the same answer, 1 over 4, 1 over 4. Okay, so we move on to factorization. So under factorization, we're going to group them into type 1, type 2, type 3, type 4 for easy understanding. So type 1 is called common factors. And so when it comes to common factors, our duty is to look for what is common among the expression that will be given to you. So for example, if I have 24x plus 6y, you need to ask yourself what is common. And you ask yourself what is common, we pick the highest common factor. So if I have 24 and 6, okay, you realize that 2 is common. 2 can go into 6, 2 can go into 24. 3 can go into 24, 3 can go into 6. So 2 can go, 3 can go. We are looking for the highest common factor, so 6. But 6 can go into itself and can go into 24. So you rather pick the highest common factor, which is 6. Okay. Okay. So now we're going to factor 6 out. So among the numbers, 6 is common. But among the variables, there's nothing common. So you bring it into brackets. Then 6 times what will give you 24 is 4x. And 6 times what will give you 6y is y. So when you finish, when you expand, you should be able to come back to the question. Let's take another example. We have 3x squared minus 9x. So what is common among the numbers? 3 is common because 3 can go into itself and can go into 9. Then we continue. So if you look at 3 and 9, 3 is common to both. If we have x squared and x, you see that x is common to both. Then you now bring it to bracket. Now 3x times what will give me 3x squared is x. Then minus 3x times what will give me 9x is 3. So we are finished. Let's take another question. We have 6x squared y cubed plus 10x squared y raised to the power 4 times z. So once again, look for what is common among the numbers 6 and 10. What's common? You realize that 2 is common to both. S squared. So we can say S squared is common. We have y cubed and y raised to the power 4. So y cubed is common. Don't forget, y is common, y squared is common, y cubed is common. We pick the highest. So since we've gotten everything that is common, we bring into brackets. 2 times what to give me 2s squared y cubed times what to give me 6s squared y cubed. That will be 3. Then we have plus 2 times what to give you 10, 5. We've already removed s squared. Y, out of y4, we have removed y3. So we are left with only one y. Then our z, which there. So that's all. Okay. So let's take another question on that. So all these are factorized. Okay, so you hear factorize, we are doing factorization. So factorize 2x into bracket 2x plus 1 plus 2x plus 1. So if you look at this question, you see that 2x plus 1 is common to both. So we factor that one out. And you'll be left with 2x, which is here, plus, when you factor this one out, you are left with only 1. Okay, so this gives you the answer. So we have 2x plus 1, the same 2x plus 1. Okay, so that's the answer. Okay, let's take the last one on type 1. If I have c plus 5d e plus f minus 4d e plus f. So whether e plus f is common to both. So we factor that one out. Then into bracket, you'll be left with c plus 5d minus what's left here is 4d. So we have e plus f. So 5d minus 4d gives you d. So we have now c plus d. And that gives you the final answer. All right, let's move on to type 2. So type 2 is called a method of grouping. So that one, in the method of grouping, we first group the terms in pairs so that each pair has a common factor. Then you proceed. So factorize, let's take some question. Factorize 2pr minus 4ps plus qr minus 2qs. So don't forget you have to first group the terms in pairs such that each pair has a common factor. So if you look at it carefully, I can group 2pr and 4ps into one bracket because we have p in common and 2 and 4 also. We can get 2 to be common. Similarly, we can group qr and 2qs in common because q is common to both. So now we move. Now what's common? To the first bracket, we have 2p being common. Then we'll be left with r minus 2s because 2 times 2 gives you 4. P is factored out already. Over here to P is factored out, so we are left with R. Then plus, what is common here? We have Q being common. So we are left with R minus, if you remove Q, you're left with 2S. And once again, the bracket should be the same. to tell you you're on track. So since the brackets are the same, we'll pick one of them. Then outside the parentheses, just 2p plus q in one bracket. So that's all. Let's take another question. So you have factorize xy minus yz minus xz plus z squared. So once again, you group them pairwise. So we have xy minus yz being pair, then minus xz plus z squared also being pair. So what's common? We have y being common. We'll be left with x minus z. If you look at this one, we have z being common. We're left with x. But over here is positive. So negative times what will give you positive is negative. So that negative times negative gives you positive. So here will be minus z. And as I said, the brackets should be the same. So since they are the same, I can pick one of them. Then outside the parenthesis, which is y minus z, also in one bracket. Let's take another question on that. So we have factorize a bx minus cx minus 2aby plus 2cy. So once again, we group them pairwise, and we can group a, bx, and cx since they have something in common. Then we can group 2aby and 2cy since they have something in common. So what's common here? You see that it's x. So we left with ab minus c if you remove x. Over here, what's common? We have 2 is common. Then we also have y being common. So we left with 2. Sorry, we'll be left with, because we have already removed the 2. So we left with a. Then we have ab. Don't forget here must be minus c. So the negative times negative gives you positive. So since the brackets are the same, we pick one of them. Then outside the parentheses, which is x minus 2y also in one bracket. Hope you are getting it. Okay. Let's take another question. Factorize 3pr minus 6ps minus qr plus 2qs. So once again, pairwise. So we can pick 3pr and 6ps because there are some things in common. Then we can as well pick qr and 2qs. They also have some things in common. So what's common to this? We have 3, as well as the variables, we have p. So left it r minus 3 times what will give you 6, that's 2. Then we have the s. Minus what's common? We have q. So we left it r. Minus times negative gives you positive. So minus, then you have 2s. So since the brackets are the same, we pick one of the one in bracket, same bracket. Then the outside the parenthesis, which is 3p minus q, and also one bracket. Okay. We move on to type 3. So in type 3, it's called a quadratic trinomial or expression. And quadratic trinomial is of the form ax squared plus bx plus c, or ax squared plus bx plus c squared. And so, to solve this, you need to find a product of a and c. And you write down the factors pairs of ac that sum to b. You need to rewrite the expression by replacing b with the factor pair obtained in the previous one. Then you factorize by grouping. Let me give an example so you understand what I just explained. So we have factorized, for example, you have x squared plus 8x plus 15. So once again, the coefficient of x squared is a, which is 1. So you have 1 times 15 being 15. Then you find the factors of 15 pairwise. So we have 1 and 15 giving you 15. And you have 3 and 5 giving you 15. So 3 and 5, you realize that these are the factors of pairs. Which of them can help you get the b, the coefficient of x, which is the 8 over here? So realize that it is 3 and 5. So we can now replace this 8 with the factors, which will be 3x plus 5x, because 3x plus 5x gives you 8x, then plus our 15. And we now use the method of grouping, which we just finished treating it, to factorize into type 1 factorization. What's common is x, so you're left with x plus 3. What's common is 5, you're left with x plus 3. Since the brackets are the same, we'll pick 1, and outside the parentheses also in one bracket. So that's how we factorize questions like this. Let's take more examples on it. Factorize x squared plus 5x minus 14. So once again, the coefficient is 1. So 1 times minus 14 is minus 14. Then the factors of minus 14 will be negative 1 and 14. Then we also have negative 2 and 7. Then in that order, we can also get 1 and negative 14, 2 and negative 7. But which of them can help us by way of adding to get 5? So you realize that negative 2 plus 7 will give you 5. So we now rewrite this as s squared, okay, sorry, s squared minus 2x plus 7x. So negative 2x plus 7x gives you positive 5x, then minus 14. Once again, we group them pairwise. What's common is x. So you have x minus 2. What's common is 7. You have x minus 2. So since the brackets are the same, we'll pick 1. Then outside the parentheses, also in one bracket, which is x plus 7. Okay, let's look at another question. We have to factorize 6x squared plus 11x plus 4y squared. So once again, the 6 will multiply the 4. And if 6 multiplies 4, we get 24. And factors of 24, we have 1 and 24, 2 and 12, we have 3 and 8, we have 4 and 6. So which of them pairwise can give you 11 by way of adding? So we realize that it will be 3 and what? 8. So we write 6x squared plus, this is having two variables. So we're going to have 3xy plus 8xy, giving you 11xy, then plus your 4y squared. Okay, so we group them pairwise. And so we look at what is common. So what's common is 3x. So we left with 2x plus y. What's common is 4y. So 4y times what will give you 8sy is 2x plus y. So since the brackets are the same, we have 2x plus y. And outside the parentheses, 3x plus 4y. Let's take another question. We have to factorize 2p squared minus 5pq minus 3q squared. So once again, 2 times minus 3 is minus 6. The factors are 1 and minus 6, 2 and minus 3. Okay. So we realize that 1 and minus 6, when we add it, we will get negative 5p or negative 5. So that would be 2p squared plus pq minus 6pq minus 3q squared. We group them. So what's common? We have p. So that would be 2p plus q. What's common? We have 3q. So that will be 2p plus q. So what's in the bracket are the same. So we pick one. Then outside the parentheses also in one bracket. So basically that's it. Now move on to type 4. And type 4 is called difference of two squares. The difference of two squares is of the form a squared minus b squared. Anytime you have a squared minus b squared, it can be factorized as a minus b, a plus b. So one is minus, the other is plus. So if I have x squared minus 2 squared, this is the same as x minus 2, x plus 2. Okay. So when you have a square on each of them, one will be minus and the other will become plus. So if you have x squared minus 9, you should be able to express this 9 as 3 squared. Then to give you x minus 3, x plus 3. Okay. If I give you x squared minus 25, all these are different of 2 squared. To factorize this becomes x squared minus 25 is the same as 5 squared. So since you have square, square, minus, that's different of 2 squared. So one will become minus, the other becomes positive. Okay. So now let's factorize the following. So if I have 25 p squared minus 9q squared, you should be able to express this 25 as 5 squared and then 9 as 3 squared. So since square is on all of them, we can say the factorization becomes 5p minus 3q. 5p plus 3q. That's all. Okay. So if you have factorized x cubed minus 16xy squared, first of all, what you need to do, since there's nothing you can do for here quickly, you need to quickly factor out first. So s is common to both. So you factor s out, we left it s squared minus 16y squared. So this 16 is the same as 4 squared y squared. And since square is on all of them and the minus, we have difference of our 2 squared, which means 1 will be minus, which is x minus 4y, and x plus 4y. Let's move on. What if you have 4x squared minus 1 over 16? So this 4 also can be expressed as 2 squared. And the 1 over 16 can be written as 1 over 4 all squared, because this square is affecting the 1 and affecting the 4. And 1 squared is 1, 4 squared is 16. So this is same as 2x all squared minus 1 over 4 all squared. So this is different of 2 squared. And we can now factorize it to be 2x minus 1 over 4. 1 is minus, then the other is 2x plus 1 over 4. What of if I have 16 factorized? So we have to factorize the following. So you have 16 m squared minus 36 over 49. Once again, this 16 can be written as 4 squared. 36 can be written as 6 squared. And 49 can be written as 7 squared. So this is same as 4m all squared. This is same as 6 on 7 all squared. So the factorization will be 4m minus 6 on 7. 4m plus 6 on 7. So that's how it goes. Okay, let's take another question. If I have h squared minus k squared minus p into bracket h plus k, we need to understand that the first bracket is a difference of 2 squared, which is the same as h minus k, h plus k, then minus p into bracket h plus k. So h plus k is common. So we factor that one out. So we have h plus k out. So you'll be left with h minus k minus p. So that's the answer. H plus k, h minus k minus p, also in one bracket. So that's all. Then to factorize 9s squared minus 6sy plus y squared minus 1, we have to factorize this. So once again, we can solve from here all the way to this. But this one can be expressed as 1 squared. So we need to solve from this to this, which is quadratic trinomial. So 9 times 1 is 9. Factors of 9, 1 and 9, 3 and 3. So 3 and 3 can help us get 6. So that will be 9s squared. This minus 6xy can be written as minus 3xy minus 3xy plus y squared. Okay. Minus 1. So we group them to type 1. What's common is 3x. So we'll be left with 3x minus y. What's common is minus y. We'll be left with 3x. So, sorry. So it'll be minus y. So the negative times negative is positive. Then minus 1. So 3x minus y, 3x minus y, the bracket are the same. So in one bracket, then outside the parentheses, also in another bracket, then minus 1. But this can be written as 3x minus y all squared. Then this 1 can be expressed as 1 squared. So now we have difference of 2 squared, which is square, square, minus. And if you have difference of 2 squared, we said 1 can be minus, and the other will be positive.